everyone, and welcome back to my video. Last time we left the ancient Greeks in pretty good shape. Aristotle explained the universe using vibes and confidence. Democritus guessed everything is made of invisible atoms with no way to check if he was right. Archimedes was centuries ahead of everyone, mostly by actually doing math instead of just talking about it. Then Rome fell, and if you only read the usual textbooks, physics goes quiet for a few thousand years. Conveniently, right before Newton shows up like he invented science from scratch. He didn't. While Europe was busy with other priorities, those Greek ideas packed their bags and moved to Baghdad. And there, people stopped just admiring the Greeks' ideas and started testing them. This is the Islamic Golden Age, and it's where physics quietly grows up. Today, three thinkers, Al-Haytham, who got so good at proving people wrong that he accidentally invented the scientific method, Ibn Sina, who got within touching distance of Newton's first law even 700 years early. It's tempting to think that the Islamic Golden Age was just a storage unit. Greek ideas boxed up, shipped to Baghdad, kept safe, handed back to Europe, in mint condition. That's tidy. It's also wrong. The real crack opens in 9th century Baghdad, inside the House of Wisdom. It was a translation operation, and translation is never neutral. Rendering Aristotle's physics into Arabic meant deciding what his ideas even meant inside a totally different intellectual world, one already full of Persian astronomy, Indian mathematics, and its own theology of cause and effect. So you got two inheritance on the same shelf. Aristotle's physics, elegant, causal, satisfying, and almost entirely enumerate. Ask him why a rock falls, and he says it's seeking its natural place. Lovely story. Not a single number. Ptolemy, meanwhile, hands you a mathematical model that actually predicts where the planets will be next Tuesday. Two different ways of being right, both filled up under natural philosophy. That tension, story versus number, is the crack. And this wasn't abstract curiosity. You needed serious astronomy and to calculate prayer times and the direction of Mecca. You needed rigorous math for inheritance law, which is genuinely why we have the word algebra today. Al-Khwarizmi wrote the book to solve legal problems. The mosque and the treasury needed better numbers, and philosophy had to catch up. Around the year 1000, Ibn al-Haytham told the Fatimi Caliph al-Hakim he could tame the Nile. He got the job, headed upriver, staring at ancient Egyptian engineering, realized that if this were actually possible, the pyramid builders would have already done it. He came back and admitted failure, which under al-Hakim was dangerous. The traditional story is he faked madness to survive and spent roughly a decade under house arrest until al-Hakim died. Confined, disgraced, with nothing left to prove, he sat down and wrote the Book of Optics. Here's the part most retellings skip. The live debate was whether vision works by the eye sending rays out or light coming in. And Euclid and Ptolemy had it backwards. Ibn al-Haytham's real innovation wasn't picking the right side. It was refusing to pick a side philosophically at all. He built dark rooms, controlled light, early chimera obscura rigs, and let absurd behavior settle the argument. Philosophy answers to observation, not the way around. It goes deeper. In his commentaries on Euclid, he asks, how do we actually know mathematical axioms are true? His later work, Resolution of Doubts, Arguably, things which correspond to one another are equal, not because it's self-evident, but because we have mapped one thing onto another so many times that the intellect just forms the judgment through repetition. Even the foundation of geometry earned through experience rather than handed down by pure reason, a fight that still hasn't fully resolved. He also proposed two cognitive faculties: imagination, which abstracts idealized shapes from what your senses take in, and distinction, which turns just images into mathematical concepts and chains them into proofs. All internal, no divine emanation acquired, unlike his contemporary Avicenna's mystical, quote-unquote, active intellect. And here's the line that ties it together. The duty of anyone examining the writings of scientists is to make themselves the enemy of everything they read, attacking it from every angle, suspecting even their own judgment, so they fall into neither blind acceptance nor unfair dismissal. That's the full epistemological principle, sitting in Cairo 600 years before Europe formally writes down it as the scientific method. While Ibn al-Haytham interrogated light, his contemporary Ibn Sina, Avicenna in the West, was wrestling with motion. Aristotle's rule was simple: continuous motion needs a continuous mover. Push something, it moves. Stop pushing, it should stop. Fine until you throw a rock. Nothing is touching it, yet it keeps flying. Aristotle's answer was air rushes around behind the rock and pushes it forward. So I think this is the kind of explanation you give when you're making it on the spot. Ibn Sina asked a follow-up question. His answer was like this: a moving object acquires something internal once set in motion, which is called mal and translated as something inclination or impressed force. The throw implants a stored tendency to keep moving, which gradually fades, which is why the rock slows and eventually drops. That's the momentum, or even inertia, just not quite finished, standing at the doorstep of Newton's first law 700 years early, and then it just doesn't walk through the door. This wasn't just a physics patch. It was doing real philosophical work inside his bigger project on causation itself. What does it mean for one event to produce another and not just to precede it? Impressed force was his answer for motion specifically. The cause doesn't need to stick around forever because it leaves behind an internal residue the object carries and spends on its own. Causation as something transferable, storable, almost like currency, spent down over time. And this idea travels. 300 years later, in Paris, Jean Buridan picks up this exact impressed force idea and pushes it one step further, naming it impetus theory, which is where the next chapter picks up. So, two different men, one underlying question: what happens once philosophy isn't allowed to just sound more convincing anymore? Ibn al-Haytham answers this with method. Test the claim, distrust even your own conclusions. Ibn Sina answers with concept, quietly repairing a broken Aristotelian idea about motion, even if the repair isn't finished. None of it happens in isolation. All rests on ideas translated out of Greek in Baghdad, carried forward sometimes intact and sometimes quietly repaired, until it crosses into medieval Europe, where John Buridan picks up exactly where Ibn Sina left off. This era isn't a pause between the Greeks and Newton at all. It's the hinge that the door actually swings on. Thank you so much for watching this video so far, and I will see you in the next video.